Hello and welcome to today's class. Standard form. This is prerequisite knowledge required to be able to read logarithm tables. So this here is supposed to go ahead and help us read logarithm tables in our next class. So what number do we say is in its standard form? So a number is said to be in its standard form if it's written in the form a times 10 raised to the power of n, where a we say usually is a number greater than or equal to 1, and it's less than 10. So basically what this means is that this number a should be between 1 and 9.9 recurring, so long as it doesn't get to 10. All right, so that is what a should look like, and n should be any integer. All right, and n should be any integer. So that basically means that n can either be a positive or a negative number. Why don't we go ahead and look at an example so that you're able to understand what standard form actually mean from this perspective. So in these examples, I'm going to write standard forms of numbers that are greater than 10 and also numbers that are less than 10. Let's begin with standard form of numbers greater than 10. For example, let us look at the number 12 here. If we are to write the number 12 in its standard form, remember it's supposed to be written in the form a times 10 raised to the power of n. And we are saying that a is supposed to be between 1 and 9. So what do we do to 12 to make sure that 12 is between 1 and 9? So we know that 12 here is the same as 12.0. Okay, we know that 12 there is the same as 12.0. So for us to make sure that 12 is between 1 and 9, what we basically do is we move this decimal point to the left so that we have 1.2. All right, so that we have 1.2. Now you note that 1.2 is in between 1 and 9. All right, now because we've moved that decimal point from where it was, then it means that the value of n here will account for the number of times we've moved and to which direction did we move. So whenever we move to the left, that's always going to be a positive integer. All right, since we moved to the left only once to get 1.2, then we're going to have the number 10 raised to 1. So that when you take 1.2 times 10, you get 12. So this here is the standard form of 12. Now for our second example, I'm going to pick a number 120. So this is slightly bigger than 12. It's a number greater than 100. So if we were to write this in the standard form, what are we looking at? Then we are going to expect that it should take the form a times 10 raised to the power of n, and that a is supposed to be between 1 and 9.9 recurring. So what do we do to 120 to make sure that it's between 1.9.1 and 9.9 recurring? So what we do, of course, we know that 120 here is the same as 120.0. So we are going to move the decimal point to the left until we get it to the range that we want, and that is the range of 1 and 9. All right, so when we move it to the left, we are going to get 1.20, of course, which is the same as 1.2 basically, times 10. And how many times did we have to move it to achieve the range 1 and 9.9? We had to move it how many times? 1 and 2 times. So we are going to therefore raise 10 to the power of 2, since we also moved to the left. Okay, so anytime we move that decimal point to the left, it's always going to be a positive number, that is as the power of 10. So for our next example, I'm going to raise a number that is slightly less than 1. All right, so I'm going to raise, assuming you are given a number like 0.1 2, 0.12, and you are told to write it in its standard form. How do you go ahead and approach this? So we know that we are supposed to have it in the form a times 10 raised to the power of n for sure, and that a is supposed to be between the interval 1 and 9.9 recurring. We can already see that this number here is less than 1, and we want it to be between 1 and 9.9. So what do we do to it? We move the decimal point to the right. So when we move the decimal point to the right, we are going to get 1.2, which is actually between the range 1 and 9, where we need it to be. However, we moved to what direction? I told you earlier on that when we move to the left, we're always going to have that value of the power of 10 as a positive integer. However, when we move to the right, it's always going to be a negative integer. Therefore, this is going to be negative 1, because we had to move only one step to achieve the range 1 and between 1 and 9.9. All right, so that's going to be 1.2 times 10 raised to the power raised to negative 1, as you can see right there. And for our last example, let's say you are given a number, let's say 0.0074, and you are supposed to write it in its standard form. Basically, we know that for it to be written in the standard form, it should take the format a times 10 raised to the power n, and that a should be between 1 and 9.9. So what do we do to achieve that? We move the decimal point so that we have 0.0074 actually within that range. So when we move it, we are going to have it as 7.4. All right, so how many times did we have to move the decimal point? 3 times. All right, and to what direction? To the right. So that's going to be negative 3. So it was 1, 2, and 3 times for us to actually achieve this standard form. So that is it for standard form. If you are having any question, drop it in the comment section and I'll get back to you. But as a bonus point, maybe why don't we look at a situation where you're given the number 46 all over 100,000. So basically what this means is that before you write it in its standard form, you want to write it as a decimal. So that's going to be 0.00046. All right, so after you've written it in that particular format, then you can always go ahead and write it in its standard form simply. So that's it for this particular class, and see you in the next one, where we'll be looking at how to read logarithmic tables. Adios.